Hello, fellow makers, and welcome to the first class on the introduction of 3D printing. Today, I'll be going over the informational side of 3D printing by talking about the history, materials and tools, the process from concept to printing, and the applications it can be applied to.
Hello again, everyone, and welcome to the first class on the introduction to 3D printing. Today, we'll be going over these 4 topics. The first one's history, the second one's materials and tools, the third one's process, and the fourth and last one is application. For history, we're going to start off a little bit more recently, not to go too far back, but in the late 80s, S. Scott Crump developed fused deposition modeling, or what's most likely you've heard of is FDM printing. You'll hear a lot of different types of printers out there, FDM, SLA. Most likely, if you're going to end up buying a printer, it's going to be FDM, which FDM is basically a hot glue gun on a robotic arm that draws shapes in thin layers on top of the other. So the RepRap project started in Britain in 2005 as a non-commercial open source research project, which got a lot of makers into technology that started popping up with their own versions of the machines for consumer market. That's why you can buy a high-end quality 3D printer for less than $1,000. What makes 3D printing unique is its ability to make complete, complex, solid objects. Most 3D printed objects can only be produced by a master sculptor or a machinist, and some 3D printed objects would be impossible to produce any other way. So now we're going to head into the materials and tools. For printing, you are limited on the materials and types of shapes for lower end models. For those types of printers, you'll only be printing in plastics with a single color, type, have limited build space, and not super fine details. Unlike a higher quality printer, you'll be able to print with higher quality shapes and have more options for the types of filaments. Here's some examples of some types of common filaments that you may hear if you've been around in the 3D printing area. So the first one is PLA, which is the most common and used filament out there on the market, or polylactic acid. Next one is ABS, which is a very strong filament, but when printing it up, it can be very temperamental, so you need to be very careful with the temperature you used, and it can have kind of an odor issue when printing. PETG, PET, P-E-T-T, there's many ways to say that, but this type of filament is basically a child of PLA and ABS. You have a very strong filament, just like ABS, but you don't have such an odor when printing, and it's a lot easier to print than ABS. TPE, TPU, TPC, NinjaFlex, Flexible. There's a lot of types of filaments out there that have these names. And what's really cool about this type of filament is, just like I said, it's flexible. You can make wristbands or even your own types of shoes if you choose to do so. Next one's wood. Yes, that's correct, wood. When printing a wood type of filament, it's interesting because when you're in the room, it actually smells like wood when it's printing out and getting melted down into the type of filament. And we have metal. Now it's not really metal for this. It's just a type of chemical that they put in, giving it that type of look. However, there are manufacturing printers and super expensive printers out there that have the ability to actually print with metal. Now, I do not know on the hand if there are those available for the consumer market, but they definitely do exist in the industrial type market. And we have conductive. Just like it says, if you need to print a little STEM project or anything that could be powered by batteries, you can actually use this type of filament instead of having to solder. And now the most scary and spooky type of filament, glow. Yes, glow in the dark. It's a very scary type of filament. Now, some other types of tools that you will see with other people who have 3D printers. It may vary for a couple of these depending on what type of printer you have, but the most common ones are going to be rubbing alcohol above 90%. The reason for that is you're going to be using it to wipe down your build plate, and you want to get rid of anything that could be on there. So the higher the alcohol count, the better. For acetone, also depends on the type of build plate where your printer will be printing on. For example, if you have the Prusa MK3 or MK3S or the Prusa Mini, you will need acetone to wipe down the print bed. It's just basically a type of moisturizer for the print bed. If you're having a hard time getting prints to stick on there, give it a little wipe and then you're golden. However, if you have the Robo R2, that type of print bed, you don't need acetone. You just either replace the build pad or you just wipe it down with some alcohol. Calipers. These are a tape measure of a small scale design. This handy tool will make it easy to measure type spaces, curved objects, types of unusual shapes, and even the actual filament when you buy. Another good idea is to get a plastic putty knife or a little mini spatula. It's just to get those printed parts off the build plate. It can be tricky, but this handy tool really helps. Even with the Prusa build plate, which is flexible, I still end up using a little spatula or something small along those lines to help get off the certain print if it's being a little finicky. The last one is flush cutters or nippers. If you're into model making, you most likely have some of these. This just helps with cutting off supports. Getting those little things can be hard with just your hands, and this definitely makes it a lot easier. Now here's some programs that you can use for 3D modeling. First one, Tinkercad. It's free and browser based, so you can use it on any computer or tablet. It's easy, fun, intuitive 3D modeling program that's great for designing objects for 3D printing, which we'll be going over in the next class. Next one's Fusion 360. Fusion 360 I'm partial to for a number of reasons. It's easy to learn. The UI has been carefully designed from the ground up to be clean, minimum, and simple. You can go from zero knowledge about 3D modeling to making some simple objects in the afternoon. It's extremely powerful. Once you get to know the basics, there's really no limit to the complexity of things you can design with it. It's easy to create simple models with it, but there's nothing holding you back from modeling a fully articulated gas engine if you wanted to. However, there are some things that you have to remember with such a powerful program. Make sure that your computer has at least the minimum requirements for it. If your system has less than what's required for the program to run, you may be able to still get it to work, but it's going to take a long time processing the different types of tools and things that you're going to end up doing in the program. So it's good to have a good computer to work with this. The higher the RAM, the better the graphics card, the better it's going to be. It's a cross-platform. It's available on a Mac and PC, and it's very stable for both platforms in my experience. It's great for 3D printing. The models I've developed in this program tend to go straight from this program to the slicing software without any problems. It's free, so if you make less than $100,000 per year using it, you could just renew it with the startup license every year and just keep going with it for free. It's not a web app, though all your files are backed up on the cloud. Rendering is taken care of there. You don't have to rely on a high-speed internet connection to use this program. The final reason why I really like this program is I basically learned completely on this. I didn't really know about Tinkercad, even though they're owned by the same company. So start off with a simpler software instead of a trial by fire like I did. And then here's the Fusion 360 logo. Now, for 3D printers. Nowadays, there are many 3D printers that you can get on Amazon or overseas, ranging from $200 to over $300,000. I'm not joking about that. They can even get more expensive than that. Though, when it gets to be that expensive, it starts to become an industrial printer that can print large objects, even a boat. There was a group of people who printed a working boat, and even NASA is working on how to design 3D printed habitats for Mars. It's really incredible for 3D printing. So I pulled up a little list of just some various printers, going from the cheapest to expensive. By expensive, for desktop users, hobby makers, that's a decent top of the line that I believe is a good printer. So the first one is the MP Select Mini V2, which is $200. Next one is the Ender 3 for $230. Next one is CR10 V2 for about $500. The Neva Magis for $567. And my personal favorite, the Prusa i3 Mark III's, which is $750. It's very reliable in my part. I've had my own for over a year, and our library actually owns one too, with some special upgrades on it. So if you ever wanted to take a look at it running, just swing by when we're open and available. So for the process. For the process of 3D printing, if you are designing something from scratch, as in not modifying a file, but making it yourself, you would first sketch out your idea on paper to get a good idea, and when the design on paper has finished, you would open up your 3D modeling software like Tinkercad or Fusion 360 and design it. After designing it, you would end up exporting it as an STL or OBJ. Next, you will end up importing your STL or OBJ file into a slicing program such as Slicer. Now, depending on the print, you would have to take a good look if it needs supports or not and how to lay it out. After designing it, you would end up exporting it either as an STL or OBJ. Next, you will end up importing your STL or OBJ into a slicing program such as Slicer. Now, depending on the print, you would have to take a good look if it needs supports or not and how to lay it out on the print bed. I'm going to show you how to do this in our next video, so you could just hold off on thinking about that for now. So then after exporting it out of Slicer, it will become a G-code. This file type is the instructions to printing. It tells the printer how tall, how wide, how to move the nozzle, and to print your object. So, you've exported your files, you're almost there to print. So now you have to prep your printer, and that can vary from printer to printer, but most of the time you just have to make sure that the filament is loaded, the print bed is clean, and it's preheated. Here comes the last step. you 3D print. You may think it's all smooth sailing right now, but it's not. There are still many issues that could happen to the printer that would have you make interventions. The machine must be prepped. The build platform must be cleaned, and getting the first print going can often take multiple corrections and adjustments both to the machine and the G-code. Those corrections can include temperature, feed rate, extruder speed, must all be carefully calibrated to achieve the direct result. Fortunately, once the machine settings are all dialed in, each successive print becomes easier until you don't even need to think about it anymore. And if you're lucky, your library already knows all those settings, so you just have to give them your own 3D model and they can print it up for you. So, depending on what you printed, you may have to end up going back to step 1 to modify the original concept to refine the model. So, applications. There are so many different types of things you can do with 3D printing. You can make art and design, costumes and accessories, fashion, gadgets, healthcare, hobby and maker, household, learning, seasonal designs, sports and outdoors, toys and games, and even replicas of things around the world. For myself, I do some practical prints to help in daily life, but I use it mainly for my hobby, which is costume making, creating things from a mask from Fortnite, Legend of Zelda, and the anime Evangelion to a rocket launcher from Overwatch. If you are willing to sit down and have the patience to design something from scratch or modify something you found online, it is worth it. The time is worth it to see something from a computer screen to it being held in your hands. Today we went over the history of 3D printing, materials, tools, process, and applications 3D printing can be applied to. Thank you for watching along, and make sure to like and follow us on Facebook to get program updates and see our next 3D printing program that will be coming out next week. Stay crafty, my fellow makers.